Now we just finished talking about electrophilic addition to alkynes. Now let's see what happens when we add water to an alkyne. Now, water is not a very good acid, so we are going to need to catalyze this, and we're going to draw up a reaction that is not very efficient. It's only going to make a trace amount of product, but you might be surprised by what it makes. So if we're adding water to this, well, it's going to substitute on this carbon, right? We've had this substrate in the previous video, and it would put an alcohol here, and then we would have a double bond left over. And those are called enols. And an enol will undergo keto-enol tautomerism, and so we actually won't make an alcohol, we'll make a ketone. Now, I mentioned that this process is particularly terrible or under these conditions. So we really only make a tiny amount or a trace amount of this product after a long reaction time. Now, just remember that initially what we're making is the enol, which looks like this. And then we'll go keto-enol tautomerism to go ahead and make that. And I have a video on keto-enol tautomerism, so I don't feel it's necessary to go over a rather lengthy mechanism in this video. So if you want to see that process, you can go and look at that other one. Now, this is a terribly inefficient process just because of just how weak the water is. So we'll need to, if we actually want to use this reaction, come up with an acid that's stronger than H3O+. Now, there's this little thing called the leveling effect. And the leveling effect just says that it's not possible to have an acid that's stronger than H3O+ in an aqueous solution. Essentially, because that is the solvent, because water is the solvent will get protonated, and then that is the strongest acid that we can have in the solution. So we'll need a system that has an acid that's much stronger than H3O+. In order to do that, we'll have to change our solvent conditions quite a bit. So if we have the same substrate, and in this case we'll add just a little bit of water, and then we add triflic acid, which is a strong acid, and then we'll need an appropriate solvent for that. So we're going to use this fluorinated alcohol. So let's see here, 2,2,2-trifluoroethanol would be what this would be called. Then we can make a pretty good yield of the product, the ketone. Just because this is a much stronger acid. Now, under these conditions, it still takes quite a while for this reaction to happen. So, even better conditions for this reaction happening quicker and a little bit milder on the acid strength is to go back to our sulfuric acid, but then we'll add another catalyst to the mixture, which is mercury 2. And when we do this, we'll use acetic acid as the solvent. Then we can do the transformation of the alkyne into the ketone much easier under much milder conditions. Now, we're still involving mercury, and some people might not like using mercury, but if you're trying to take an alkyne into a ketone, these conditions are a little bit simpler, probably more practical in the laboratory.